Again, you might want to look at the solutions for these ones because they do them a little bit differently. So just remember there are lots of different ways to do these. So these are the same as question 6, but now we've got definite integrals, so we can forget our plus c. Again, I'm going to rationalise the numerator. So I'm multiplying by the root of 1 minus x on 1 minus x, root of 1 minus x. So I'm multiplying by 1, but that just gives me 1 minus x on square root of, that's still negative 1 to 0. So it is going to be a negative x squared here, so I'm going to get a positive 3 minus 2x and minus x squared. Hopefully I've got that right. dx. All right, so again, I'm going to do the same as what I was doing before. So if I think of the derivative of the function under the third, I want a negative 2x. And I've got a negative x at the moment, so if I put a half out the front, I'm going to make it a negative 2x. And as well as that, you can say I want a negative 2x and I want a negative 2, so I'm just going to make it a negative 2. But remembering that means I've got negative 1, and what I actually want is that positive 1 there. So I've got to add a positive 1. And while I'm adding that positive 1, I'm going to, not to waste any lines, I'm going to complete that square. It's a negative x squared, so I know I want that negative x squared there. The middle term is negative 2, so I know I want actually a positive 1. That'll give me a positive 2x, and the negative in front gives me the negative 2x that I want. The extra term there that I'm getting would be 1, which is and it's a minus 1, so actually I want 4 in order to get that 3 there. Okay, so that turns out to be really nice. Again, here I'm going to get, if I made that u or u squared equal to everything under that third, I would be getting 2u du on u, and that would cancel and that would cancel. So I just get the integral of 1 du, which is u, and our u being everything under here. I could have changed to u limits. Just realized I forgot the limits. I could have changed to u limits, but this should be in there as well, but I forgot. And sometimes it's easier, just go back to x's, so it doesn't really matter which one you use. Over here you can see we've got the inverse sign. What have I done? What have I done here? Did I forget to put a 2 out the front? So I have a minus 1, and I wanted a positive 1, so I had to add 2, and I forgot. How did I do that? So minus 1, and I had to get that positive 1, so I had to add 2. So I'll put that 2 in there. All right, so I've got plus 2, and this is an inverse sign. We know it's an inverse sign of x plus 1 over the a, which is 2 in this case, because of that square root of 4. This is negative 1 to 0. Okay, so subbing this in, I can put 0 in, I get inverse sign of a half minus inverse sign of negative 1 plus 1 is 0, so 0 there. Here, when I sub 0 in, I just get square root of 3. When I sub negative 1 in, I get 3 plus 2, so 5 minus 1 is 4, and square root of 4 is 2, so that's a minus 2. Plus 2, inverse sine of a half is 30 degrees. Inverse sine of 0 is 0. So I've got a root 3 minus a 2 plus pi on 3 as my answer. All right, so let's look at the next one. In the same way, we are going to rationalize the top again and hopefully remember to balance it up. So we've got negative 1 to 0. Let's just cheat a bit. So skip ahead. We're going to rationalize like that. So we're just going to get an x plus 2 on top. And on the bottom, we've got under the square root, whatever 1 minus x times x plus 2 is. So what do we have? A positive 2 negative x and a negative x squared. Hopefully that is correct, Amundo. All right. So again, if I think about the function under the surd, I want a negative 2x, negative 1 as my derivative. So in order to do that, I'm going to put a negative half. Then I get the negative 2x there that I wanted. But I also need a negative 1, so I'm just going to pop that negative 1 in there. All right, 2 minus x squared. So again, here I've put in a positive 1. And I actually want a positive 2, so I'm actually just going to add 1. That'll give me a positive 2. And at the same time, I'm going to complete the square. It's a negative x squared, so I'll do that. Half the middle term is a half. I'm going to make it positive because of the negative out the front. So the third term will be a quarter, with the negative is negative a quarter. So I have to add that quarter in. I want 2, so I'm going to have 2 1/4, which you can see is 9 on 4. So we'll put 9 on 4 in there. That'll be a nice inverse sine. All right. What have I done? I should have a 3 on 2 out the front, not a 1. So let's just check that. I've got a positive 1 and I want a positive 2. That looks right. Got a positive 1, yes. What have I done? What have I done? What have I done? I cannot see. What have I done? All right, hopefully you guys can find it. So this is what's looking not quite right. So let me just go back and check here. So I've got negative 1 to 0. We should have, and we want a negative 2x, negative 1. So I've got a negative 2x, negative 1. And that means I've added in 1 times a half is a half, not 1. Okay, so that makes sense. So this is incorrect. So you can see my line here. Wish you were here to pick me up. So negative half times negative 1 is positive a half. Positive half, but I want positive 2. So I need a 1 1/2 more. So that means I've got 1 1/2 more. All right, that's fixed, thank goodness. So again, we're going to have negative half here. If I make the substitution of u squared equaling 2 minus x squared, I'm going to end up with 2u du on u here. That cancels, that cancels. I've just got a negative. So I've got the integral of u. I could even get rid of the negative by swapping the limits if we wanted to. So we would just get the u being 2 minus x squared. And I can get rid of the negative by swapping the limits around like that. All right, the second part, this is our inverse sine. So we've got inverse sine of, you can see here we're going to have x plus a half all over 3 on 2. That bit is going to be negative 1 to 0. So I mean, we could simplify here, or you could just put it straight in. When I sub 0 in, I get a half divided by 3 on 2, which is the same as a third. So I've got inverse sine of a third there. When I put negative 1 in, I'm getting negative a half on 3 on 2. So that's negative 1 on 3. So I've got negative inverse sine of negative 1 on 3. Now, it's handy to note that inverse sine is an odd function. So that negative there, this negative I can change to a positive and put the negative out the front. So this becomes negative, negative, which is also positive. So I've actually just got 2 lots of inverse sine 1/3. So that gives me, if I've got 2 lots but times 3 on 2, then I've got 3 inverse sine 1 on 3s there. And over here, if we sub in negative 1, we've got 2 minus 1, so that's 3. Minus 1 is 2, so we've got root 2. If we sub in 0, we have root 2 as well. So they cancel each other out, and our answer should just be 3 inverse sine of a third. All right, so 1 and 3 is, we can't find an exact answer. It would be approximate, so leaving it as inverse sine of 1 and 3 is fine for that one. All right, so let's go on to C. Now, let's just move this over. So we've got C. Oops, so we're looking at C, hopefully. All right, so again, if I rationalize the numerator, we are going to have just x plus 1 on top. Under here, we've got x squared, we've got 4x's, and we've got 3 times 1 is 3 dx. So this looks like it could be a nice one, 0 to 1. Again, if, looking at the derivative of the function inside the third, it's 2x plus 4. In order to get that 2x, or to keep that x the same, I need a half out the front. And then I force the 4, but remember that I have to balance that. So hopefully I've balanced it correctly this time. So half of 4, I think, is 2, and we're looking for 1. So I need to subtract 1. All right, so minus 1 of these, and completing the square, so half of the middle term is 2. So that gives me the x squared, it gives me the 4x, it also gives me a 4, so I have to minus 1 to get that 3. All right, so hopefully we're on track and remembering it's a definite integral. So again, if you made the substitution, you would get 2u du on u. So you're really just integrating 1. I could do it. So, but really you're just integrating 1 du. I'll write it anyway. 2u du's on u's. So they all cancel. So we're just integrating 1, which becomes u, and u is all of this. All right. So again, you could change the limits to use, and then you can, so it'll be quite easy, but either way you're doing about the same amount of algebra. The second one is a log, because it's a x squared, it's a negative under a third, but it's not negative x squared, so we know it's the log one. So we've got log of, we have the x plus 2 plus everything under the third. So x plus 2 squared minus 1. All of that between 0 and 1. So if we sub in with 1, we get 3 plus 3 squared is 9 minus 1 is 8, so that's 2 root 2. 2 root 2. I'll keep it like this, minus log. So subbing in 0, we get 2 plus 4 minus 1 is 3, so that's root 3. All right, subbing in 1 here. 1 plus 4 is 5, 6, 7, 8, so that's 2 root 2. If I sub in zeros, I just get minus root 3. Here I could use log laws. Give me a fraction, but that's okay. So I would have that. Now it is a negative log, so I could actually turn that upside down and make it a positive log. They seem to like positive logs in the book answers, so we'll just turn it upside down there. Now it's a positive log. And that would be our answer. Hope that helped.